So we're here with a FOVI3D here at SID Display Week, and we're looking at your special display right here. So hi, so who are you?
I'm Thomas Burnett. I'm a founder of FOVI3D.
And what are we looking at here?
This is a true light field display, so it's a full parallax, perspective correct light field display.
So is it something that can be viewed with the camera, or need two eyes?
No, you can view it with a camera.
So what am I looking at right here?
Well, you're looking at a pyramid moving, so we're animating a light field in near real time.
How's it possible that I can see all these angles by moving around?
Well, because we're projecting all those angles. We're projecting the light that would reflect off that object if it was actually there. And so it's...
How does that work? How do you do this?
Well, you're not actually seeing me directly, right? You're seeing light reflecting off me and impinging on the lens or your eye. Instead of having that light reflect off me, if you just project that same ray attribution onto the eye or onto the camera, you'll get a perspective correct image.
I don't understand. So do you have a graph you can show some what is going on here?
Right. So what you're looking at here is we call it a HOGL for a holographic element, but you can consider it a directional pixel in that depending on how you're looking into that microlens, you're seeing a different ray. And the idea is when you have an array of these HOGLs, each having distributing the correct ray information, when you look into the display, you'll see a 3D aerial image. And so, if you're familiar with a light field camera, this is sort of the inverse of the light field camera.
What's a light field camera?
Well, a light field camera captures the direction and intensity of light in a field, so to speak. And so, light field display is just the inverse of that.
How many angles, or it seems they're different angles, or
yeah. So there's 12,000 unique views that this display is capable of doing.
12,000 from every different angle.
Yeah, from every different angle.
But there's like an area where it's too much, right?
Yeah, you're outside of the projection frustrum.
So how big is the projection area?
About 90. It's a 90-degree projection frustrum.
And so is this kind of like the ultimate hologram kind of?
It's a holographic display like you would see in Star Wars. So that is the idea.
Since when are you working on this?
Well, I've been working on this kind of technology about 15 years, but FOVI's been working on it for about 3.
It's your company?
My company.
So what's next? What's the market?
Well, what's next is to make larger light field displays, color. Markets are military, oil and gas, medical, maybe esports visualization, anything where you want to collaborate over complex 3D data.
And what are those kind of like squares?
So you're looking at 20 4K OLEDs that are all tiled together. So
20?
Yeah. So they 4K. Haven't. Yeah. It hasn't been color balanced. So you're looking at the non-uniformities of all those OLEDs.
It's because there's a bezel-less small OLED displays?
Right. Yeah.
But they're all 4K.
That's correct.
There's nothing inside this box, right?
Well, there's a bunch of drive electronics that manages the signals to those OLEDs.
It's just flat, is it?
Well,
it looks like there's something in there.
No, yeah, it's flat. The photonics and optics is very, very narrow. This is all drive electronics down here.
And what's different on this one?
Different microlens. This has a lot lower spatial resolution, but it has a lot higher angular resolution. And so this display can project something taller but with less detail. And that display can project something with more detail but less height.
Taller.
Yeah.
Because people have been talking about wanting to do holograms for a long time, right?
Yeah. So
why isn't it like everywhere yet?
Well, it's pretty hard to do. This is actually 108 megapixels, or mega rays in this little box. And so it's quite a phenomenal challenge to control all that light and compute all that light.
108 megapixels?
Mm-hmm.
Like a 4K is 8 megapixels, right?
Yeah.
So you're a bunch more.
Yeah, and it's 108 megapixels in a 9 centimeter by 9 centimeter square area.
How do you get those tiny 4K displays?
Well, Micro OLED actually makes these 4K displays.
Like micro displays?
Yeah, they're 4K micro OLED displays from Micro OLED. They're in France.
And they fit right here.
Yeah. Well, I mean, we had to tile them together. That was complex. But
there's no bezel.
Well, they have a small bezel, so there's a relay optic on top of them.
You're lensing them together, so there's no seam.
That's correct.
And how do you make a huge one in color? Is it just
We just
gonna be
tile
the same?
more of them, yeah.
Just more of them?
Yeah.
Do you need to drive more of them? You need a bigger chipset or something?
You need more of everything, more OLEDs, more driver boards.
Is there FPGA in there?
There's 6 FPGAs in that box.
The secret which ones or?
Yeah, there's some secret sauce in there, but there's 5 driver FPGAs and there's another FPGA that sort of manages them all.
So at some point we'll all have holograms at home, right?
That is the idea.
How soon is that? Like in a couple years?
10 years probably. You'll start
10
seeing
years?
them in your homes.
But they always say 10 years, right? That's what the joke
No,
at the
everybody here
keynote.
says 2 years. We're saying 10.
You're saying 10. But so 10 years everybody has one?
I would like to see them proliferated in 10 years.
Then it feels like somebody's in a room, or what does it feel like?
No, you'll get an experience like this where you can sit around a display and watch like a football game in 3D with your friends.
But you could also feel like your friend is in the room right there.
I don't think we're going to get that level of fidelity in 10 years. I view it more of, maximizing the 3D fidelity of an image volume about 6 inches deep.
And so no matter where I position the camera, there's always an image.
That's correct. A perspective correct image, just like in real life.
Everywhere.
Everywhere. Well, everywhere within the projection frustrum.
Because there's all these like glasses-free 3D
This is
displays.
a true
And
glasses
they're like
free.
every time you move, it's like jumping.
Yeah, so that has those view zones. This doesn't have zones. This projects a field of light, a perspective correct light.
So how long have people talked about holographic displays?
Well, I mean,
30, 40, 50 years or
Yeah,
something?
definitely.
But why is it not yet?
Well, it is kind of hard to put these things together.
They didn't have 108 megapixel displays back then?
That is true, yeah. It's still hard to make them.
Yeah.
Yeah.
So what if a huge company comes by and says, hey, we want to speed it up?
It's all about money now. I mean, the whole reason that we're here is to socialize that this is not science fiction anymore, right? You can make these displays and, there are some challenges, but they're all addressable. And so, we've had some pretty good responses from industry people that could solve a lot of those problems, whether it's compute or photonics or optics.
What do you need solved? What's this? Without saying too many secrets.
I think that compute is a challenge, and I think being able to preserve the detail of all these rays when they're angularly distributed is also a challenge. So those are the two fundamental things that need to get solved for more commercial adoption.
Why is it just yellow?
Brightness and pixel density.
So if you had all colors, it'd be hard to make it look like that.
Well, we took a color OLED and we doped all the subpixels to be yellow-green, and we picked yellow-green because it was brighter that way.
But you want to have full color?
Yeah, we can do full color. Yeah.
You can?
Yeah.
Where are you based?
In Austin, Texas.
And so what's next? What if some of the industry people came over and said, we really like that, we want to have them?
Yeah, so we can make, I think, with the right investment, we can make mobile displays, we can make large tabletop displays and anything in between. I think the architecture is the same, it's just where you put your engineering dollars.
This red company, they
phone.
have a phone. How does that look?
It looks pretty good, actually.
But what is their technology? How's
Well,
it
it's
different?
similar to this, I haven't seen too much of it, but it's a single-user, light field phone that produces a 3D aerial image. You kind of hold it out here, and I think it looks pretty good.
And there's other companies working on holographic stuff, right?
I think, but that company is Lay, and I think they've done a good job on the mobile stuff. I don't know if there's anybody else who's got a full-on, desktop light field display like we do. I think Samsung has had one in their booth in the past years, but I haven't seen it this year.
All right, cool. So looking forward to that at home, right? And everywhere?
Yeah.
Okay.
A couple of years.
All right.